Alright, we are starting chapter 2 in this video. Chapter 2 is all about quadratic functions. Quadratic functions. Okay, a little bit about quadratic functions. It's this right here, y equals x squared. Okay, if I were to graph that equation, y equals x squared, it would look something like this. It's this nice U-shaped graph, and it's kind of a curve on both sides. That is the quadratic function. The quadratic function has to do with this type of graph, and we talked about this in chapter one, not type of graph, type of equation. And we talked about this in chapter 1. Okay, every bit of that equation has something to do with moving the graph. Okay, and we're going to go down here first, and we'll go back up. First of all, this A right here. The A is a vertical shift, or not shift, stretch or shrink. Okay? A stretch makes it skinny. I'm just going to write skinny. A shrink makes it wider. Okay? Remember, vertical stretch. If it's a vertical stretch, it's A is bigger than 1, and if it's a shrink, A is between 0 and 1. It's that fraction. Okay, this x minus h, this moves it left or right. H units. Okay. Remember, if it's x minus h, it moves right. And if it's x plus h, it moves left. And then this last part, plus k, moves up and down. Moves it up and down. Okay? And if it's plus k, it goes up. Minus k goes down. Okay, knowing this information, let's try to match these graphs. Okay? So let's just start here. X minus 2. Well, that's minus 2, so it's going to move right 2. And something we didn't talk about down below is this negative. What does that negative do? It flips it. What does that mean for flip? It means that if I have my graph, my normal graph was that U, right? This graph flips. It goes down now. And the vertex goes right 2. So let's try to find that. It's flipped over and it goes right 2. Flips and goes right 2. Do you see anything that flips over and just shifts to the right 2? Yeah, right here. D. Right? My vertex was at 0, 0 for y equals x squared. So my vertex, this point right here, it goes right 2 points and it flips over the x-axis. So we're going to say that first one is D. Not bad. First one is D. Number 2, describe that one. Well, this x minus 2 moves right 2. plus 2 moves up 2. The vertex is going to go right 2 and up 2. Looks like this one right here. Start at 0, 0, we go 1, 2, and then up 1, 2. Right there. C. And how about this one? Well, we have x plus 2, so that's going to move left 2. This minus 2 moves it down 2. And this negative right here flips it. So it flips, goes left 2 and down 2. Let's that one right at A. We go over 1, 2 and down 1, 2. Oh, no we don't. Yeah, we do. My marking is just off. Yep. That's A. How about G? G. This moves it right 2, so I'm going to say R2. This moves it down 2. And it's 0.5. Does that make it wider or skinnier? Makes it wider. Okay, where do you see right 2, down 2, and it's skinnier? Or wider, sorry. Right there at F. Right at F. F. I'll circle all these. G. Or sorry, E. E. Here's goes right 2. We'll just say R2. And then this 2 right here makes it skinny. So we're going to go right 2 and it's skinny, right at B. Right at B. And the last one, left 2, up 2, and it flips over. Do you have any other of those? Left 2, up 2. It flips, left 2, up 2. Nope, should be E. Okay? The more you do this, the quicker you'll be at all the different types of movement. Okay? So, can you write an equation of this quadratic function whose graph is shown? Well, I'm just going to focus on the vertex. Where's that vertex? Looks like it's right 1 and down 2. Okay, well, let's say f of x equals, do I have an A in front? It doesn't look necessarily wider or skinnier, so I'm not going to put an A. All I really care about right now is that vertex. And it goes to the right 1, so we need an x minus 1, that's squared. Then it goes down 2. Perfect. Okay, now we can kind of look, we can use a graphing calculator to see if it's skinnier or wider. That's actually what we're going to do. We're just going to say, we're just going to compare the two graphs. Y equals, and then in parentheses, x minus 1 squared. Then it was minus 2. Okay, and we can kind of, I can't zoom on. Yeah, I can. Kind of look at these points. I like to look at the major points, like that goes through 0, 1. Does this graph here go through 0, 1? Looks like it, yep. And it goes through like 2.5, it looks like, and negative 0.5. Oh yeah, close. Right there, right? So we're good. We're good. That is our equation of the graph. Moving on, we have some definitions here. The quadratic function is written in this form, what you've seen, f of x equals a times x minus h squared plus k. The parabola is the U-shaped graph. Good. The vertex of the parabola is, I'm going to write this as a picture. If I have a graph here. And my parabola is like this. My vertex is that lowest point. And if I had a parabola that went this way, it'd be my highest point. It's either the lowest or highest point of a parabola. And the vertex form is what we wrote up here. That's vertex form. Okay, and that's just a quadratic function. Okay, that's our vertex form. We can find the vertex with that equation. We talked about this. We talked about this. Okay. Here in our extra practice, we're just going to describe the transformation of f of x equals x squared, and then we're going to graph the function. Okay. So for these problems, 2.1, not really looking for a spot-on perfect graph. And that'll be in 2.2. Right now, I just want you to describe this transformation. So it's x squared plus 4. This plus 4, what does that do? It moves our vertex up 4. That's it, right? That's all we know about this parabola. It goes up 4. And here's what I mean. I want your vertex to be spot on. Your vertex should be spot on. But your graph, it's going up, right? There's no negative, so it's just quickly. Okay? This one. X minus 1 squared. Where does that x minus 1 go? Moves it right 1, and this minus 3, down 3. So we got to go right 1. You got to be careful here, counting by 2s. Right 1 and down 1, 2, 3. Parabola? Looks like that. Next one. X plus 9. That plus 9 moves it left 9. What does that negative do? What does that negative do? It flips it. Flip. Okay, so we got to go left 9. Let's say it's counted by 3s. 3, 6, negative 9, right there, right at 0. Just moved it left 9. And instead of moving our graph, or right in our parabola going up, it's going to be going down. Again, I'm not looking for a spot-on parabola. I'm looking for the correct vertex. This one is just going to be down 7, so 6, 7, right at negative 7 here, and then it goes up. That's how quickly we can do it, and probably describe it down 7. This one, down 6. That 1/3. What is that 1/3? It's a stretch, right? It's a vertical stretch. Okay. Vertical stretch, which makes it wider. So go down negative 6. Okay, and it makes it wider. So just make sure you do something like that. Okay. Negative 4x squared. And that negative 4 is inside the parentheses. Okay, so number 6 is weird. It's different. Let me erase this stuff. Because it's in parentheses, this negative 4 is affecting only the x. So this is a reflection in the y-axis. Okay? And because that 4 is inside the parentheses, it's not a vertical stretch. It's actually a horizontal shrink. Okay? Which is very weird. Very weird. And now, if you can think, a horizontal shrink makes it skinny. Okay? It's different than it's opposite of vertical stretch, vertical shrink. So a horizontal shrink makes it skinny. Okay, now a reflection in the y-axis. That really doesn't make any sense to me because any parabola, right? If right here, this is my parabola. If I reflected that in the y-axis, this line here would become this line right here and vice versa. They're the same line, they're the same graph, right? So that reflection in the y-axis doesn't do anything for graphing purposes. Okay, the horizontal shrink makes it skinny. So, how about our vertex? Does our vertex move left, right, up, or down at all? No, it stays right at 0. And it's skinny. And we're going up. Okay, it's not down because it's a reflection of the y-axis. It just stays skinny. Just like that. Okay, that's all I'm looking for with these. Can you describe the graph? And then can you write a rough sketch? So on your last problem, consider the function f of x equals negative 10 times x minus 5 squared plus 7. Describe the transformation of the graph of the parent quadratic function, then identify the vertex. Okay, so let's first describe the transformation. Remember, every little thing moves this graph. We'll start with this negative. What does it do? Flips over the x-axis. Okay? This 10. What does that 10 do? That 10 is a vertical stretch of 10. Okay? Have I moved my vertex at all yet? No. All I have is it flipped over the x-axis and it became skinny. I haven't moved it left or right. The only thing that moves the vertex is right here, x minus 5, so that's going to be right 5. And this part right here, plus 7, of 7. So we just described our entire function. We described all the transformations, but only these two right here move my vertex. And it's from 0, 0, it goes right 5 and up 7. So what's my new vertex? 5, 7. Okay, that's it.